Welcome to this lesson on the area of simple polygons. Today we're going to talk about how to find the area of parallelograms, rectangles, triangles, and trapezoids. First, we need to start off with two vocabulary terms though. One being perimeter. You should already be familiar with perimeter. Perimeter is the distance around a figure. Okay, so the distance around a figure. So if you were to walk around a park, that would be the perimeter. You're walking around the outside of it. The area is the number of square units inside of a figure, the space a figure takes up. So if you were to take that park and walk, the whole entire inside of it, that would be the area. Or when you're playing with the parachute in gym class, the flooring that the parachute covers, that's the area of the parachute. All right, so we know the area formula for rectangles and squares. We know that it's base times height, or what we call length times width. We're going to shift over to the words base times height for a couple of reasons. When you talk about volume, that really helps, and when you're talking about composite figures and other quadrilaterals and polygons, it definitely helps to know what the base is instead of talking about length or width. So base times height, which is just the base, so whatever the shape is sitting on, times how tall it is. Now, the reason that a parallelogram can also do base times height is because if you cut off this extra triangle piece right here that you're seeing, and you shift it over here, it makes a rectangle. Now, you have to imagine that this other piece is no longer here, so I'm trying to find a way where I could show you it like that. Most of all, you're just going to have to use your imagination. So let's just white that out. So that piece is now gone. So now you just have that rectangle instead of a parallelogram, which is why base times height works. The only difference is your height is now, instead of being right here, your height is from the corner down to the base, because the slant is a different measurement. So we're just going to practice. So when you're finding the area of a rectangle, we know that we just take the base times the height. So in this case, we take 15 and we multiply it by 9. Okay, and to do this quickly in our heads, we can say that 9 times 10 is 90. 9 times 5 is 45. So 90 plus 45 gives us 135. And then it's square feet. Okay, now the reason that it's square feet, we're going to take a look at this here, is because when you multiply, you have 15, oh, and I'm sorry, this is square inches. You're multiplying 15 inches times 9 inches. We said 15 times 9 is 135. And then you have inches and inches. So inches times inches, which is inches squared. The squared also tells you that it's two dimensions, your base and your height. So it implies that it's area. So anytime you see square units and they're talking about measurement, you know that they're talking about area. So for the next one, we have the parallelogram, and you have 1 1/4 foot is the height. So 1 1/4 times 2 1/2. Right? And we know that when we multiply using fractions, we have to turn them into improper fractions first. So I multiply and then add, and I get 5/4 times multiply and then add. So 2 times 2 is 4, plus 1 is 5, times 5/4, which is going to give me 25/16. 16 goes into 25 once, 9/16 left over. So the area of this is 1 9/16 square feet. That should be a Q. All right, moving on to triangles. So what you need to notice about triangles is that if you take the triangle and you duplicate it exactly and then line up the slanted edges, here you make a rectangle. If you duplicate the scalene triangle and attach it on their slants, you have a parallelogram. Same thing with the equilateral triangle, and the same thing with the isosceles triangle. So if you take a look at this, you know that if you take each of these triangles and double them, you get a rectangle or a parallelogram. So on its own, a triangle is half of a rectangle or half of a parallelogram. So here you would have rectangle, and the other one, so rectangle or parallelogram. All right, since we know that the area formula for a rectangle or a parallelogram is base times height, and we know that a triangle is half of that, that means that the area formula is going to be 1/2 times the base times the height. And again, the height is going to be from the point of the triangle down to the base, unless you have a right triangle, whereas that way this leg here will be the height. And we'll talk about that and have an example of it. So we have 3 examples that we're going to try together. The first one right here is what looks to be an equilateral triangle. And we have to remember that this is our height. I'm going ahead and switch to the black marker now. So I know that it's 8 is my base times 7 is my height, but I only want half of that because a triangle is only half of a parallelogram. So I can do this one of 2 ways. I can do 8 times 7 and then take half of that, or I can make life a little bit easier on myself, and I can do half times 8 times 7. I know half of 8 is 4 times 7 is 28. So the area of this triangle is 28 square centimeters. Again, if at any point you feel confident in doing these on your own, please go ahead and try them on your own and just come back to check your work. Okay? Do not move on to trapezoids though without going through one example. Okay, so we have 6 yards times 5 yards. This time 5 is going to be my height. So my base, so it's 1/2 times my base, which is 6. So here's my base, here's my height, times 5. Half of 6 is 3, times 5 is 15. So the area of this triangle is 15 yards squared. You can say square yards, yards squared. Either is fine. You can write the SQ, you can write the 2. Notice I've written it this way with the exponent of 2, and I've also written it using the square feet, the SQ and the FT. You can write it any way that you want as long as you make sure that you have that. If you don't have it, it's incorrect. It implies that it's a different measurement. All right, and then here we have a scalene triangle. Again, you have to look and see that the height is actually right here in the middle. So here's my height, here's my base. I have 1/2 times my base of 20 times my height of 12. So I get 10 times 12. To do this simply in my head, 1 times 12 is 12. Tack on that extra 0 at the end, and I have 120 square feet. All right, so trapezoids are a little bit more complicated, but they have the same type of idea as the triangle. So if you take a look at a trapezoid, you have the top base and the bottom base. Now your bases are going to be the 2 lines that run parallel to each other. Those have to be your bases. Again, if you take the trapezoid, copy it exactly, and then flip it and connect it, you make a parallelogram. So if you take this base up here and connect it to the base on the bottom, you've now made a parallelogram. But you have to keep in mind that now your base isn't just this second base, it's base 1 and base 2. Okay, so how this works then is you have to add your bases together. So you have to basically add your top and your bottom, add your two parallel lines to get your base. Then, again, you're going to multiply it by your height, just like you would for a parallelogram. And again, a trapezoid is only half, so we have to take half of that equation. So it's half times base 1 plus base 2 times h. And yes, this has to be in parentheses, and you have to add these together before you can multiply. All right, so let's take a look at this and see how it works and go slowly. So again, here's your base 1. Up top, the 10 and a half is your base 1. And base 2. So then if I were to flip this and put it together, I would have to add these two pieces. So those are the two pieces that I'm going to put in first. Okay, and then I know that my height in this case is that dotted line. Again, it's from the corner all the way up to the top, or up to the base, I should say. That's my height. It's not this. This is a slant. This is not your height. This is something different. Okay. So then here we have to add the 10 and a half and the 4 3/10 first. And when we do that, we get 14 8/10. Okay, and we can do half times 14 8/10 times 6. Again, since it's multiplication, we can do it in any order that we choose. I chose to take half of that base and do 7 4/10 times 6. And in doing so, I got an answer of 44 4/10 meters squared. Okay, if you feel comfortable, go ahead and try the next one on your own. Otherwise, we are going to do one more example together, and then you do have these 3 problems here that I'd like you to try on your own as your U-tries for the next class. All right, so again, first we need to identify our bases. So here are my 2 parallel lines. So if I want to take a look, these are my 2 lines that run parallel, so these have to be my bases. So I know I have to add those together. So I have to add 4 plus 12 before I can do anything. I want half of my base, and in this case, this is my height because I do have that right angle. So when I have those right angles, I can just count this as my height because of the fact that I have the right angle right here. Right? And my height then is 10. I don't want to mess with the 10 because it's nice and easy to multiply anything by 10. So I'm going to add my 4 and my 12, which gives me 16. Half times 16 times 10. Half of 16 is 8. Times 10 is 80. So my answer is 80 inches squared for my area. Again, I do want you to understand why the area formulas work because it makes it a lot easier to memorize them. So keeping in mind and remembering that, oh yeah, a triangle and trapezoid, they are half of a rectangle, so it's half the base and the height. That helps you memorize these formulas. And then remembering that, oh, if I flip my trapezoid, my bases aren't equal like they would be for a triangle because of the fact that the triangle has points. So this point makes it so that way there's no added height to it, or base as well. Okay, I want you to try these couple of problems on your own. Again, we will continue to talk about these area formulas and why they are what they are to help you memorize them. But please make sure that you're using them and that you have them written down, and you can use them at this point. I want you to try these 3 problems on your own. And as always, if you have any questions, please be sure to email me or write them down so we can go over them in class.